This is another video for Thumpel. This one is about catalysis, and she's asked how are we supposed to know about the catalysis, or how are we supposed to use this system. All right, now the short answer is it's on the syllabus. So this is the syllabus, and the equation you're supposed to know is this one, the I minus S2O8 minus reaction. And this, I found it here. This is the reaction you're supposed to know, and it's from the syllabus. Okay, so it's from the syllabus, but I found this from your book. Okay, 22.8, I think is where I found it. But there it is. It's a very common reaction. It's nice because we get a color change. We have colorless on this side, and we have a nice brown, ready brown solution on this side. So this one often comes up, and it's a very classic reaction. We can use starch and all sorts of things to measure the progress of this reaction. Okay, it's just an interest reaction. Now, interestingly, as you'll see, this ion here, and I can't remember what it's called. Is it the persulfate? I honestly can't remember the name of it, but this guy here forms the SO4 minus, and this is the sulfates. Now, as you can see, this has a charge of -2, and this has a charge of -1. So naturally, these ions will repel each other. So there'll be some sense of repulsion between these two, and the repulsion will mean it's a slow reaction. Okay, and slow reactions are ideal for catalysis, and that's why this is a very classic case of a catalysis reaction. Okay, so what we're going to use to catalyze this, we're going to use the Fe2, Fe3 plus system. And let's have a look. Why is that good? Well, Fe2 plus will form Fe3 plus and an electron. So going the one way, going left to right, it gives up electrons, and going right to left, it sucks in electrons. So this guy, the Fe2, is going to be a source of electrons, and this is going to be a sink of electrons. In other words, this one's going to suck in electrons, this one's going to give us electrons. It gives us a nice sort of a midway point. If you work out the electropotentials, it's right in the middle, this reaction, and it allows the reaction to happen nicely. So let's start. We can start anywhere. Let's start off with the iodine. So 2I minus has got to become I2. We can see that from this reaction. So, well, obviously the iodide must lose electrons. So which one of these is going to suck up the electrons? It's going to be the Fe3 plus. So let me draw this in red so we can see Fe3 plus. Now, obviously, it's going to form Fe2 plus. So this looks nicely like step one. Okay, but it looks like it's balanced because it's got two iodines on the left and two iodines on the right. It's got one ion on the left, one ion on the right. But something that students forever fail to remember, it must balance in species and charge. And this one doesn't balance in charge. On the left, we've got 2 minus and 3 plus, which is -1. On the right, we've got +2. So that's not right, is it? So let's try and balance this. Let's put a 2 here and a 2 here. What do we get now? Let's get rid of this. Whoopsie daisy. My computer's a bit slow today. I don't know why. Oh, it's not working for some reason. Let's go there and there. Did I push something I shouldn't have pushed? I guess I must have. All right. Anyway, let's try this. Does this work? Now we've got 2 minus here, and 2 times 3 is +6. So overall, we've got +4 here. Here we've got 2 times 2 is +4 as well. So that's the reaction with the iodide and the Fe3 plus. So this is step one. Okay. So step one is this. It's beautiful. Step two. Well, now what's going to happen now? Now we're going to have the S2O8. So let me write that in. Now we're going to have the S2O8 2 minus. This is going to become SO4 2 minus. Okay, now there's two of those. So now what we're going to get? Well, we're going to get Fe2 pluses. Sorry, let me get rid of something there. That's annoying. For some reason, I'm picking the wrong tool. That's what's wrong. All right, so we've got 2 minus on one side, 2 minus on the other side. All right, so we've got two of these. So we've got -4 on the right-hand side. So now, obviously, I've got to regenerate my Fe3 pluses. So Fe3 plus must be on this side. It must do. And Fe2 plus must be on this side. Okay? Because we want these regenerated. All right. So let's have a look at the charges now. We've got -2 and +2, so it's 0 on the left, and -4 plus 3 is -1. So that's not right. So let me try my trick I used last time, timesing that by 2. -2 and +4 is +2. 2 times -2 is -4, +6 is +2 this side. So this is step 2. Okay, step 1, step 2. All right, and as you can see, if I add these two equations together, and this is vital for catalysis. Let me change color so you can see what I'm doing. All right, if we add these two together, that will cancel with that, and that will cancel with that, and we'll get this equation. Now, you might say, well, which equation comes first, the iodide or the persulfate? It doesn't matter because it's a circular thing. Which one's the catalyst? Is it Fe2 plus or Fe3 plus? Both are, because they're both regenerated and both used up. Okay, one isn't the catalyst and the other isn't. They're both the catalyst. It doesn't matter which step comes first because they both happen, time and time again. All right, I hope that makes sense. Let me post this now.